Hello everyone, welcome back in this video lecture series on refrigeration and air conditioning. Up to this lecture, we have already covered the part related to refrigeration system. From this lecture onwards, we shall be talking about air conditioning systems. So, air conditioning system or the ACs, which I think every one of us is quite familiar with. You see, refrigeration, when we talk about refrigeration system, we essentially want from a refrigerator is to cool down things only. That could be edible items, that could be any storage item. But when we talk about air conditioning system, then cooling is not the only thing we require, right? For example, from an air conditioning system, apart from cooling, we require cleaned air, we require control of moisture also. So overall, we want our refrigeration system to cool down things, whereas we want our AC to provide a comfort conditions for human being. Right. So that is why we essentially need to alter the state of the air which is surrounding us. And I guess that is why it is called air conditioning, because we are conditioning the air, we are changing the state of the air which is surrounding us so that we can feel comfortable. Right. And to understand this, first we need to understand some of the terminologies which are associated with air conditioning systems. So let's start. So, first of all, when we say air conditioning, the first word is air. So, let us first try to understand what is air, or what do we really mean when we say air. So, air, as we have already studied in our school, is a mixture of gases. Mixture of gases, right? So, for example, we have studied that air comprises of nitrogen, oxygen, argon, carbon dioxide, etc., etc. And if we calculate its composition, then by volume percentage, nitrogen roughly com is around 78%, and oxygen constitute to almost 21%. That is nearly 99% of the air. Similarly, argon is somewhat approximately 0.93%, and carbon dioxide is approximately 0.03%. And this is by volume, right? So this is what we have studied in our school level, on the basis of which, when we calculate the molecular mass of air, then it turned out to be somewhat near to 29. And the gas constant of air is assumed to be 0.287 kilojoule per kg Kelvin, right? But when we talk about air conditioning system, then we call this thing not just air, but we call this thing dry air. What do we call this thing? Dry air. And I'll tell you the reason. Why do we call it dry air? The reason is pretty much simple. The air which is surrounding us right now and throughout the year, 24 by 7, this air contains not only the gases, but also water vapor, right? So the air which is surrounding us is actually called moist air. So this is nothing but dry air plus water vapor. So if we want to create comfort conditions for us, which depends upon the air which is surrounding us, then we will have to study not just the dry air, but the mixture of water, vapor, and dry air. And the study of moist air is called psychrometry. Psychrometry. Okay. So this is basically we are going to talk about in air conditioning system. Now, when we say the water vapor is present in the air, then there has to be a limit up to which water vapor can dissolve in dry air. And that thing is called saturated air. I'm sure you are already familiar with the name saturation, saturated air. So it simply means when air has dissolved maximum possible water content. It becomes saturated air, right? So what about the other times when the air does not contain the maximum possible amount? Then this is unsaturated air. And this is on the basis of which we can define a very important property, which is nothing but degree of saturation, which is commonly represented by a term mu. So degree of saturation is nothing but by what percentage the water vapor is present in the air. So which is defined as mass of water vapor, mass of water vapor in 1 kg of dry air to the mass of water vapor in same amount of dry air when it is saturated. When it is saturated. You see? So this is to denote by what percentage the water vapor is present in the air. Okay. The next important thing that we are going to define is humidity. So this thing is called humidity. Sometimes it is called specific humidity. Also, it is called humidity ratio. And it is commonly represented by symbol omega. So omega is defined as mass of water vapor present in 1 kg, 1 kg mass of dry air, right? So if you carefully look at this definition, degree of saturation, then you would notice that mu is nothing but omega divided by omega saturation. That means humidity of unsaturated air to the humidity of saturated air, right? And if we try to represent it in terms of a formula, then it can be calculated as 0.622 PV upon PT minus PV. Whereas PV is partial pressure of water vapor, whereas PT is total pressure of the air, right? In a similar continuation, now we are going to define absolute humidity. Which is defined as mass of water vapor present in 1 liter volume of dry. In the same category, the next definition, which is very important, is relative humidity, commonly represented by symbol phi, which is defined as mass of unsaturated vapor to the mass of saturated vapor, which can be represented in terms of pressure also. So pressure of unsaturated vapor to the pressure of the same thing when it is saturated. So I'll put it in terms of words also here. Phi can be defined as mass of water vapor present in unit volume of air, volume of air to the mass of water vapor in same volume when it is saturated, when it is saturated at same temperature. You see? So this is relative humidity. So let me give you an example. If you just open Google Map and you search for the weather reports at one particular location, then you would see it will show you the humidity as say 30%, 40%, 80%. Then that humidity which we see on weather reports, let's say 30%, this is nothing but relative humidity, right? The next definitions which I'm going to talk about is some temperatures which are associated with psychrometry. First temperature is dry bulb temperature, or called DBT. So it is dry bulb temperature is nothing but a temperature measured of an unsaturated air by a simple thermometer. It is the temperature of unsaturated air taken by an ordinary thermometer. Right? So it simply means if you just put a thermometer in a room, then the temperature shown by a thermometer would be a dry bulb temperature, right? So what do we mean by dry bulb is also going to be discussed a little later. So just hold on a second. The next thing is wet bulb temperature, or WBT. So wet bulb temperature is, so let us say this, I'm sure you must have seen a thermometer, which is generally a liquid in glass type of thermometer, which we use for measurement of fever. So this is something like this, right? In which you will see some of the scale markings are there on the outer periphery. And in between, some kind of liquid. For example, mercury is filled here, right? So what happens when we expose this thermometer to temperature gradient? This mercury gets expanded because of thermal expansion. So this part here, this part here is called bulb. The part which gets exposed to the temperature. Okay. So when we say dry bulb temperature, we simply means that the bulb of this thermometer is kept dry as it is not covered by anything. But in wet bulb temperature, what we do, we cover this bulb by some wet cloth or some cotton wool. So this temperature is temperature recorded by a thermometer when its bulb is enclosed or covered by a wet cloth. Okay. So the next definition is dew point temperature. The last definition, which is important here, is dew point temperature, or called DPT. So you see, the water vapors present in the airs are in vapor form. And when it gets cooled, the water vapor present in the air also gets condensed into liquid form. So the temperature at which this condensation starts is called dew point temperature. the temperature at which the water vapor present in the air start condensing into liquid form is called dew point temperature. See, so just one piece of more information is when relative humidity is 100%, right? The entire amount of water air has got fully saturated, then dry bulb temperature becomes equal to wet bulb temperature, which is equals to dew point temperature. So all three temperatures becomes equal to each other. When? When the air is fully saturated, when relative humidity is 100%. Okay. These are some of the references which I've been using. Thank you very much.